Welcome, dear students. So, this is another episode on the chapter Refraction. So, in previous episode, I am actually teaching the refraction chapter. Okay, from basic to slowly we are moving to the advanced level. If you missed my previous episodes, we already discussed about the reflection of light, the basic concepts of on light. Okay, then you can follow my previous episodes. All are available in Free Scholar channels, and all the topics I will try to cover so that it can be helpful for all the students from class 5 onwards to class 12, and also later on some content on graduate level and master degree level also I will upload. So keep continue my channel. So today, as per the as in the last episode I discussed, okay, the observer, okay, what how the observer can watch any object outside the water. Okay, it may be a fish or it may be any other observer. So what we have seen that within 98 degree of the cones, okay, the angle of the cones is what, 98 degree. Okay, so all the objects which is under which is in this particular range of the cone, okay, so that particular range, so suppose this is the cone, okay, so this will be what, 98 degree, and this is the area. Okay, so from, if you take your eyes over here, so from that whatever the object lie in this region outside the water can be viewed, okay, by the fish or by any observer under water. So these are under water. Now, so this is what the radius are, okay, and suppose this is the height, from the surface of water, this is h. Okay, so now we will today see what will be the how the relationship of this, okay, and what should be the radius of the this circle, okay, so through which the fish or the any observer can see the outside objects. Okay, so let us now draw. Let us draw. So suppose this is the surface between the air and water. This is the water. So this is where we can see the fish. Okay, so it is the fish, suppose. Okay, so fish can see the object, it's 98 degree. So this is what, this is the midpoint. So suppose this is R and this is the depth H. Suppose this is A, this is B, this is C. Okay, so and it is nothing but 90 degree. Okay, so what, let the depth of fish from surface be h. Okay, so the depth of the fish from the surface be h. That means what, this part is also vertical distance is 8. Okay, h. Okay, now let radius is equal to smaller. Okay, so what we know, and this is what, this is the angle of incidence, that means what, the critical angle. So light will pass from this, and if it is more than 40 theta c, then in case of other ray it will be total internal reflection. Okay, so this is the theta c. So what we can write, tan theta c. Tan theta c means what, perpendicular by base. So perpendicular is what, AC by base means what, AB. So what is AC? AC means nothing but the radius, and AB means what, the depth. Okay, so tan theta c means what, sin theta c by cos theta c. is equal to R by H. So what we can write? Sin theta c, again I am writing the same thing, sin theta c by cos theta c is equal to R by H. Now what do we know? Sin theta c means, yes, in my last episode you see sin theta c is equal to 1 by mu. Mu means the refractive index of water. Mu is the refractive index of water. Okay. So there is a relationship. So 1 by mu divided by cos means what? Root over 1 minus sin square theta c is equal to R by H. Therefore 1 by mu divided by root over 1 minus 1 by mu square is equal to R by H. Okay. We are putting the value of sin theta 1 by mu, that means sin square theta c means 1 by mu square. So what we can write? 1 by mu divided by root over mu square minus 1 by mu is equal to R by H. This will be cancelled. So therefore R is equal to what? H divided by root over mu square minus 1. So this is the relationship between the R and the H and the mu. Okay. So or we can find out the radius, okay, of this cone by using this formula, where H is the perpendicular distance or depth of the fish from the surface of water. Mu is the refractive index of water with respect to air. It is air medium, okay, and it is water medium. Okay. So and H already I explained, R already I explained, mu already I have explained. So this is how we can prove the relationship between R and H, or we can find out the radius of the cone. Okay. R is equal to H divided by root over mu square minus 1. So many numeric problems can also come by using this formula. You have to solve. So obviously we will solve some basic numeric problem as well as some advanced level numerical problems. Okay. So now moving next. Discuss some why diamond shines very brightly. Okay. What diamond shines very brightly? And if you see a diamond, okay, then you see all the surfaces are not shining very brightly. Some of the surfaces are shining very brightly. Okay. So it is because the critical angle between the diamond and the air is only 24.4 degree. Okay. So the critical angle, okay, of diamond with respect to air is 24.4 degree. Now whatever the ray will enter, so diamonds are cutted in multiple surfaces. The diamonds are cutted into multiple surfaces. So whatever the ray enters inside the diamond, most of them have the critical angle, okay, more than in angle of incidence more than 24.4. That means what? In this all the cases, what will happen? The total internal deflection will take place inside the diamond. Okay. After multiple total internal deflection, some rays for which the angle of incidence in that particular surface, okay, is less than its critical angle. That means less than 24.4. Only from that surface the ray will come out. Okay, from the diamond. Okay, and those surfaces will shine brightest than the other surfaces. Okay. So suppose if a diamond, these are the surfaces of the diamond. Okay, these are the surfaces of the diamond. Okay. So if any rays enters, then what will happen? So critical angle, the angle of incidence of the light will be more than its critical angle. So total internal reflection will take place, and it will incident on another surface inside the diamond. And if that also the angle of incidence will be greater than the critical angle, then again total internal reflection will take place. So after multiple total reflection for multiple rays, one surface will be there. For that, the angle of incidence will be less than its critical angle, and from that surface more amount of rays will come out. Okay, so that surface looks very bright. Clear? So that's why if we see the diamond, some of the surfaces looking very bright. Okay, and most of the light will be trapped inside the diamond. Okay, due to the total internal reflection. That's why as a whole the diamond shine very brightly. So I think you have understood this. Okay, moving next. One thing I am telling. Suppose this is a container having some, it's not full with water, having some water in it. Okay, having some water in it. Clear? So now, clear, having some water in it. Now if a test tube is immersed partially, okay, in the water, then from outside the water, if you see the test tube, then you see, suppose your eyes is here, you see the portion which is not immersed in the water, okay, and it is also full of water, and this part is empty. Now see, the test tube also, this tube is also full of water and this part is empty. Now suppose if you see the test tube, which is this part is full of water and that part which is outside the water is empty. If you see the test tube from outside water, you see that portion is very bright. Okay, so you know why? Okay, this is also due to total internal reflection. I am explaining. Okay, so when the rays will come, here it is water medium and it is water medium. Okay, same medium. We are neglecting, as the diameter of this container, okay, test tube is very thin. That's why we are neglecting the glass medium. So that is what the rays are entering from water to water. Okay, the rays are entering from water to water. Now here the rays are entering from water to, here it is nothing but air. Vacuum means what? Air is there. Okay, so the critical angle of this medium, means water, with respect to air is 48.5 degree. Okay, that is the critical angle. Okay, so if the angle of incident is of the rays from water to air is more than theta c, that means 48.5 degree, then what will happen? Total internal reflection will take place. Total internal reflection will take place, and reflected ray will go to our eyes. Reflected ray will go to our eyes, and this part, you see the rays from water to water medium. That's why the rays are passing. But as this part is vacuum, okay, but this part is water is there. So what will happen? The rays will fall on this, and when it try to enter, but the angle of incidence is more than 48.5. That's why the total internal reflection will take place. And due to this total reflection, reflected ray will come to our eye, and this part will shine very bright. Okay. So if we have a test tube, a part of it is full of water, and it immersed partially, okay, inside the water, then the portion which is vacuum, okay, but inside the water, that part will shine very bright. Okay, due to this phenomenon. So I hope you have understood this. Okay, so next we are moving to the next topic. Okay, another things. Suppose we have a glass of water. Okay, we have a glass of water. Now, suppose this is the layer, last layer of water. So, if we a glass of water, okay, now and it is okay, it is also made of glass. Clear? So, if we just lift the glass upwards and see from one side, you see the upper surface of water shines. Okay, why? Because see the rays will come like this, okay, and for that what we know, 48.5 degree is the critical angle for water to air, and if it is more than, suppose it is theta is more than theta c means critical angle, then what? Internal reflection will take place and this reflected ray will enter in our eyes. Okay, so that's why this surface will be, this reflected ray will enter in our eye and this surface will be very bright. Okay, it seems to be very bright. Okay, so these all phenomena, why the diamond actually looks like very bright. Okay, why the test tube that I already explained. Okay, that portions will look like bright. Why the glass? Okay, a glass, if we hold it up and see from one side, okay, from below, then the surface will look very bright. Okay, so these all type of phenomena actually due to the total internal reflection. So I will try to do some experiments on that also. Okay, so continue to watch my channels. Okay, obviously some experiments will also be done on this topic. Okay, so see you in the next video. Thank you.